okay? So we're gonna switch to English now because batch 1355 was taught in English, okay? So I'm just gonna talk a little bit about this batch. It's a data science full-time batch, so we're on the same schedule as 1350, okay? So they've been hailing at it for 9 weeks straight with little to no stop in between. So this is the picture of everyone in this batch, all right? We have some stressful faces, which I think is part of the course for data science. We also have a lot of bugs and bug fixing. That's also part of the course for Wagon. Here we have some of the students who actually came to our campus on picture day, so they were looking really, really sharp. These are the pitches that went through. Well, the ones that actually got to be pitches, 2 of them actually went through. We're gonna watch the presentation of their demos today. One in particular that I really wanted to highlight was Caramello Scanner, which didn't go through, but it really won my heart. I really wanted it to go through. Not actually because of that slide, but this one. Because this one really won me over. It didn't happen, but who knows, maybe one day it will become a project. So today we're gonna be watching the presentations of 2 really special projects. The first one is Librae. I'll let the people who made it talk more about it. I won't interfere in their presentation, but you can check it out, a little spoiler right there. The second project we'll be watching is Filmaholic. I'll also let the participants speak more about it, but again, just a little spoiler of what's to come. And finally, you guys voted in your projects. You worked at it for 2 weeks straight, if I'm not mistaken. So, well, as we've always said here at Wagon, talk is cheap, show me the code. So I'll be asking the guys at Librae to come over and take over the stage to talk about your project.
Alfredo, are you there?
Yes, I'm here.
Nice, perfect. So, hello, folks. Thanks all for coming. Those who are watching live on YouTube and those who came. I'm Nathan, and I'm here with João and Alfredo, who is directly from Mexico City. And today we will present Librae. It's a project who has the potential to reshape the way we communicate and we connect with people. Our proposal is centered around the convergence of cutting-edge AI technology and the wide world of sign languages, specifically Libras, the Língua Brasileira de Sinais, which is the Brazilian sign language. But before we start, let's play a game, shall we? Who here in the crowd understood me? Most of you didn't, and it's not your fault. What I have said is, I'm sad because I'm not understood. And 5% of the Brazilian population feel that way. Seamless communication should be accessible to all. However, those who communicate using Libras find themselves with communication gaps and isolated still today. Limited accessibility, misinterpretation, and equal participation are the main challenges these people face.
Well, this tool allows us to facilitate communication with individuals with hearing disabilities, contributing to their inclusion in society, although deaf individuals constitute a minority. It is essential that everyone has a what? Oh, well, everyone has equal opportunities to communicate and participate in society. Our mission is to promote the inclusion of all individuals regardless of their ability to speak or understand sign language. That's why we've developed Live AI, a tool that enables communication with hi. Well, as I told you, that's why we developed Live AI, a tool that enables communication with people who use Libras. With Live AI, you can capture videos or images of hand gestures and movements, and our artificial intelligence will provide you with accurate translations. Well, we envision a range of exciting applications that could harness the power of AI-driven Libra recognition to create a more inclusive society. For example, education enhancement. Educational institutes could adopt the technology to facilitate more inclusive learning environments for students who communicate using Libras. Sorry. Other one could be culture exchange. The technology could be employed in cultural events and exhibition to enable real-time translation of sign language into spoken language.
Well, I will talk a little bit on how have we tackled the problem, people. So we have divided our work in mainly in three work fronts. First, the backend. So we developed a deep learning CNN model, which is a model that is widely used to train with images. We also developed a backend Python API. So it's basically a connection between the model and the front end. This API is prepared to receive an input as an image from the user, pass through the learnings of the model, and translate it to the output. And we developed a front end, so it's a React web application. It's a web page, and we also have the mobile version. Some of the challenges that we have faced, we had difficulties on finding the data. So for example, numbers, we couldn't find many data of numbers, and also movements. So some words and letters in Libras, they have movements, and we couldn't find data for that. And also it's very sensitive to models to learn with images. So for example, if we change the lighting, the skin color, the quality of the image, it impacts a lot the result of the model. So you have to train with a wide database. Also, we spent a whole day trying to create our own data set. So we spent, like me, Alfredo, and Nathan, we spent a full day taking pictures from our hands. We took around 15,000 pictures from our hands to feed the model and train it with a wider data set. So it was a tough day, but fun. And a little bit of the results that we achieved. We have a model with 90% of accuracy with the test set, which is a set that we downloaded from the internet. But unfortunately, for now, it has a lower accuracy when we talk about webcam and phone pictures. This is a point of further improvement because of the sensibility I told. It's a bit difficult for the model to learn with many variations of pictures. So, okay, now it's time for our demo. Let's just explore the Libra MVP. We have three ways to upload the pictures. First, you can load from the file. You can drag and drop or select in your machine. You can take a webcam picture, or you can take from your phone. So we have a QR code if you feel free to use. And again, the disclaimer for webcams and phone pictures is still not working very well. So let's do the demo here. Let me just. First, I will upload some pictures of the set, okay, just to show. Let me find it here. So this sign is an A, and it will. I will try it. So an A. We also put the top most probable letters other than A, okay, so just to check the model, if the model is at least almost getting it. Let's try another one with, I don't know, F. Okay, so as I said, with the test set, it is good. Now we're going to try with the webcam. Maybe it's not that good, but we'll try it. Also with the white background, because... So this is a C. Let's try it. No, it got it on the second place, so that's why we put those second place. Let's try F. This is an O. No, it got the O in the second place as well. Before the presentation, it got it right. So that's the law of Murphy.
It's shy, it's shy.
This is the F. At least one was right. Nice.
Okay, so we were limited on time. We had 2 weeks, and we couldn't achieve all we wanted. Most of the time we spent training our model, so it's understandable. We have an ambitious project, and we wanted to do lots of things, but we faced lots of challenges, as you saw. Beyond only uploading pictures, we wanted to upload video as well, so that we could work with signs that require movement, such as, for example, the Z. It's like this, so we have to draw it. We couldn't do it with images. And for us, our ideal structure for our application would be so that the user goes in its phone, he opens our native application instead of a web application, and he can either upload a video or an image, or open directly the camera phone and receive in real time predictions without needing to upload them. And as well, another thing that we wanted to do, but we have this issue of time, is to widen the words that the AI could predict instead of only using static letters. This is LibreAI, and I hope you liked it. And I hope it helps to unlock voices and bring the world together with AI.
Thank you guys, that was awesome. I was really happy that you guys actually got it on the third try. Now we're moving on to Filmaholic. Guys, if you could come over, please.
So hello guys, today we are in the name of Filmaholic. I'm Bernardo, this is Bruno and Robert. He's virtually with us today, and we are here to present a a movie recommendation system called Filmaholic. And to start with, I believe there's a consensus between all of us that when it comes to deciding which movie to choose, it is quite a bit of a hassle. And that's why we're here. We're here to facilitate this and make our decision making when it comes to selecting the next movie better and pretty much made for us based on our decisions and our inputs. When it comes to the data overview, we were considering the 20,000 most active users. So the 20,000 users that were the most present when it came to reviews, making the ratings, and the tags. So there were 93,000 tags, which are words or a few phrases that describe the user's perspective of the movie. And finally, we were using 1,500,000, actually quite a bit more, but around 1,500,000 ratings from different movies that were in our database. For this project to become feasible, there are a few preparations that we have to do, also called pre-processing of our data. So first of all, and pretty much the essence of our project, we have to categorize if the movie was liked or disliked by a user. And for now, we were using a benchmark of 4 out of 5. So if the movie is 4 or above, it is considered a movie that was liked by the user. Otherwise, it is considered a disliked. When it came to the tags, we did pretty much a tag profile for the users. The top 20 tags that are most related to the liked movies and the disliked movies inputted by the users, so the most common ones given the inputted movies. There are also the tags profile for the movies themselves, so for each movie, the tags that appear the most. And finally, we also did all of these were then data frames, by the way. And finally, when it came to genre profiles, we did a similar idea to the tags. This time, we were considering for each user the composition of the genres of the liked and disliked movies. So for the liked movies, let's say 0.5 out of 1 or 50% were dramas, then 25 comedies, and it went on both for the liked and the disliked movies. So now for the development of the model.
Yeah, so when it comes to the model, following what Bernardo just explained, so we did train 2 different models. So in one of them, we considered the genres the user likes and dislikes. And for that, we did a neural network. And in the other model, we did a random forest model, which considers the tags the user is or is not applying to the movies he likes the most. So, for instance, if the user applies the tag nice ending to a lot of movies he likes, the system is going to try to recommend other movies that are very commonly related to this tag. And then we did a combined model at the end, which is a linear regression that basically combines both, so gets the prediction from the first model and prediction from the second, and see which one performs better. So turns out the genres model performed a bit better, so the weight of the genres model in the linear regression will be a bit higher than the random forest. And for this we used Vertex AI, which is a cloud platform from Google, so only feeding, that enables us to train the model. And now we can, now we can do a demo. So here, just to make this faster, we select some random movies, and we're going to try to see which is this user's best recommendations. So what's happening here behind the curtains is I'm predicting the rating this user will give for every single movie in our database, and then just sorting it and getting the top 10. I think it's worth mentioning like the score of our model. So when we trained it with other users already in the data set, it could predict the rating that user gave to a specific movie within a range of ±1, 70% of the time. So from references we got from the internet, that seems pretty good. When it comes to recommendation systems, the accuracy only goes so far. Even if you give me like 5 movies you like and 5 movies you dislike, I won't be able to pinpoint your 10 favorite movies all the time. So it has a limitation when it comes to accuracy, but 70% from what we saw seems fair. And then these are the recommendations for this user. So nice to see a Brazilian movie in there.
So yeah, this is the demo of our Filmaholic platform and project. On these past few days we have been talking a lot, and there's a lot to explore still. If we're brief here, we could even the idea of liked and disliked movie can be very subjective, because some people are more and less demanding when it comes to liking a movie, and this is reflected on the ratings. So we are working and considering expanding that, and maybe clustering the users according to their demands and how well they receive a movie. And there are several other ways that we can explore and expand our project. And thank you very much. We hope you guys don't have any more struggles when selecting movies by using Filmaholic. And yeah, that's it. Thank you.
Congrats, guys. Great presentation. Another round of applause, if you will, for the entirety of the batch 1355, including Alfredo and Robert, who couldn't be here. Now we're going to switch back to Portuguese, okay, to talk a little bit about batch 1350.